Introduction. Welcome to today's lecture on bipolar junction transistors, or BJTs. BJTs are one of the most fundamental semiconductor devices used in amplifiers, switches, and digital circuits. In this video, we'll cover what BJTs are, their structure, working principle, modes of operation, and applications. Structure of a BJT. A bipolar junction transistor is a three-terminal device made of semiconductor material. It comes in two main types, NPN and PNP. Each consists of three regions: the emitter, the base, and the collector. The emitter is heavily doped to inject charge carriers. The base is thin and lightly doped, and the collector is moderately doped to collect carriers. Working principle. The BJT is called bipolar because it uses both electrons and holes as charge carriers. In an NPN transistor, the emitter injects electrons into the base, and most of these electrons move into the collector. In a PNP transistor, the roles are reversed, with holes being the majority carriers. A small base current controls a much larger collector current, making BJTs excellent amplifiers. Modes of operation. A BJT can operate in four modes depending on the biasing of the emitter base and collector base junctions. Active mode, used for amplification. Saturation mode, used for switching on. Cutoff mode, transistor is off. Reverse active mode, rarely used. Characteristics and equations. The current gain of a BJT is denoted by beta, which is the ratio of collector current to base current. IC equals beta times IB. The input characteristics resemble a diode, while the output characteristics show how IC varies with VCE at constant base current. Applications. BJTs are widely used in amplifiers for audio and radio frequency, switches in digital circuits, oscillators and signal modulation. Though MOSFETs dominate modern electronics, BJTs are still crucial in analog and power applications. Conclusion. To summarize, BJTs are versatile semiconductor devices that can amplify or switch signals using both electrons and holes. Understanding their structure and operation is essential for any electronics engineer. Thank you for watching.